Welcome to this session of Class 9 Mathematics, and I'm your Arun. This is Chapter 4, Linear Equations in Two Variables, and we have seen in the last class the graphical representation of linear equations. And we infer from the last class what we have done. We infer that the coordinates, that is, see, I told you the solution of the linear equation is written in the form of ordered pairs, namely A and B. This is your x coordinate and this is your y coordinate. When we draw the graph, this is x and that is y, and that represents the value of x and y in the linear equations. That is, the values A and B when substituted in x and y. This is not to be confused with this A and B. This A and B are values of x and y, and this this value satisfies the given equation. That is, when you substitute these two values in x and y, it satisfies the equation. It gives you, when you substitute here, the result is 0. So this satisfies the equation, and this point lie on the graph. And if a point lies on the graph, we say that it is a solution of the given equation. But when we have some other point not on the line, we conclude that it is not the solution of the given equation. You understand? So now let us see at another example to demonstrate the graphical representation of the linear equation in two variables. Now let's see the algorithm. I've told you we have a method. We rewrite the given linear equation in this form so that it will be easier for us to find the values. So the algorithm states that ax plus by plus c is equal to 0 is the general format. From that we have the value for y, we reduce values for y is equal to minus of ax plus c divided by b. Okay, so for in any equation, any linear equation of two variables, you just rewrite the given equation in the form of y, y in form of x, so that it will be easier for you to find the values of both x and y. Now, given equation is x plus y is equal to 7. So, we rewrite the given equation as y is equal to 7 minus x. Okay. Now, I substitute values for x, or I assign values for x so that I get values, corresponding values for y. Now, 7 minus 0, when x is equal to 0, what happens? 7 minus 0 is 7. Okay. So, the next value is, I substitute 2 for x. So 7 minus 2 is 5. Now I substitute minus 2. See, 7 minus of minus 2, integer subtraction. So 7 plus 2, which will become 9. Okay, addition becomes subtraction, and the additive inverse of minus 2 is plus 2, so it is 9 here. Next, when I substitute 7 for x, the value of y becomes 0. And when I substitute 8 here, 7 minus 8 is naturally minus 1. Okay, that is 7 minus 8. See, 7 plus minus 8. So what does integer addition says? Both are of different values. You subtract and put the sign of the greater value. So you subtract, put the sign of the greater value, that is 8. So minus 1 is your answer. So we have got the values for x and y. What we need to do now? We need to draw the graph. So draw the graph. The lines x-axis, x dash, this is negative x-axis, y-axis and negative y-axis being perpendicular to each other, and this is the origin. So origin have points 0, 0, isn't it? Now we see the maximum point in x is 8. So we mark 2, 3, 4, 5, 6, 7 and 8. Okay. In the negative direction we have minus 2. Okay. Next in y we have maximum, that is 9. See to that it is equally spaced. So we have marked points on the Cartesian system. So now let us mark the points here. First is 0, 7. See, x-axis 0 and y-axis it is plus 7. So this is your first point, that is 0, 7. Write it in the form of ordered pairs. Okay. Next is 2, 5. So where is 2? X-axis 2 and 5 in the y-axis. So this is your 2, 5. Okay. Now next is minus 2, 9. Where is minus 2? X-axis minus 2 and you have 9 here. So this is minus 2, 9. Okay. Next is 7, 0. Where is 7 here? This is 7 and y-axis 0. So 7, 0. Okay. So always note that, see, note this point 7. See, 7, sorry. Actually, see, what is it? 0, 7. Written minus 7. Sorry. Okay. Now, see here. See, observe these 2 points. I'll explain it later, but just observe these 2 points. See, 7, 0, the coordinates, and here the coordinates are 0, 7. See here 7 in the x-axis, we have taken 7 here in the x-axis, and for y-axis it is 0. Here x-axis it is 0, the x-axis point, that is the axes are 0 and the y coordinate is 7. So along the y-axis you have x to be 0 and along the x-axis you have y to be 0. Okay, so note that. Next is 8, minus 1. What is 8, minus 1? The 8 is here and minus 1. 8, minus 1. See, verify you have marked all the points, right? Yes. Now, let's join the points. Use scale to draw lines. So, this is the straight line which I have drawn. So, I have taken both positive and negative points to represent the line, and see, you have a straight line here and the points marked all lie on the line. So it means the coordinates, see, the coordinates of the points which lie on the line satisfy the equation. Here x plus y is equal to 7. So these points which lie on the line satisfy the equation. So obviously these points satisfy the equation because we have derived these points only from the equation, so it naturally satisfies the equation. Now let us take some other point. So let me take 4 and 3. See, I've taken 4 and 3. What are the coordinates in this point? 4, 3, isn't it? So I've taken 4, 3. Let us substitute 4, 3 on the line. X on the equation x plus y is equal to 7. So 4 plus 3, x is 4 and y is 3. So this is 7. So, sorry, this is absolutely satisfying, isn't it? So 4, 3 which lies on the line is a solution for the given equation. Whereas let us take some other point which is not on the line. So I take 6 and 2 here. See, this is the point 2, 6. X-axis point, y-axis, abscissa and ordinate 2 and 6. I have taken 2 and 6. Let me substitute here. See, x plus 5 is equal to 7. So what is this? 2 plus 6 is not equal to 7 because this is 8 is not equal to 7, isn't it? So 2 plus 6 is not equal to 7 because 8 is not equal to 7. So 2, 6 which doesn't lie on the line is not a solution of the given equation because the coordinates which lie on the line satisfies the equation, hence they are solution for the equation. Now we have taken some point randomly on the line which lies on the line, it satisfies the equation, whereas a point which doesn't lie on the line doesn't satisfy the equation. Likewise, you can extend and can verify for some points, negative points on the line to see whether they are solution of the equation, and you can see anywhere points taken. See, I take for example 5 and minus 2. See, 5 and minus 2. If I substitute here, x plus y is equal to 7, 5 as x and minus 2 in y. 5 plus minus 2 is 3, which is absolutely not equal to 7. So the point which is away from the line, which is not on the line, is not a solution of the given linear equation. So that you should bear in mind. The points which are on the line are definitely the solutions of the given equation. You understand? So we have seen the graphical representation of linear equation, and we have also seen the points which are on the line and the points which do not lie on the line, and the interpretation for these points on the line and not on the line. Okay, so now after seeing the straight line, linear equation forms straight line on the graph, we'll see some more equations and we'll study about those. We'll see some more lines actually, and we'll derive equations from it. Okay, so let's have the x-axis and the y-axis, negative y-axis perpendicular to each other. Now let me mark points here. So I take values so that you'll understand more clearly, and I draw some lines for which we can derive equations. We'll see what is the equation for it, corresponding to it. Now, to start with, let us take the x-axis. Okay, to start with, I take x-axis. Now let's see what will be the equation for x-axis. X-axis, the horizontal line, the horizontal axis which passes through the origin. 0, 0 is your origin, which passes through the origin. Now let's see what is the equation for x-axis. Now let us take some point. See, this is 1, 0, isn't it? We represent the points like 1 is from x-axis, y-axis it is 0 here. Now take this point 3, 0. Likewise, take here minus 3, 0 and minus 4, 0. This point is minus 4, 0. Now just observe all these points. What you have, the point which is common in all the 4 points is that is the coordinate which is common in all the points is the ordinate, that is the y coordinate. See here, the y coordinate, isn't it? Y coordinate or the ordinate is 0 for all the points. If you note, for all the points it is 0, isn't it? Because see here y is 0. Okay, so what do you infer from this? The equation for x-axis is nothing but y is equal to 0. So when you write y is equal to 0, it represents nothing but the x-axis. So similarly, in y-axis, let us mark the point 0, 3, because y-axis 3 and x-axis 0. And here, this is 0, 1. If I mark a point here, it is 0, minus 2, and if I mark a point here, it is 0, minus 4. Do you understand? See, x-axis, first we write the abscissa, that is x coordinate, and then the y coordinate, isn't it? So the x coordinate here corresponding to this point, x-axis, see there is no length here, there is no distance here, we have not marked a point here, we have marked a point on the y-axis. So x is 0 and y is 1. Now here x coordinate is 0 and y coordinate is 3. Here x is 0 and y is minus 2, and x is 0, y is minus 4. When you observe all the points, the coordinate which is common in all the points is the x coordinate, which is 0 on the y axis. So the equation for y axis is x is equal to 0, because when we say x is equal to 0, that is there is no point for the x coordinate. There is no point on the x axis, that is all lie on the in origin. See, regarding x axis, the points are corresponding to the origin, isn't it? It is 0. So x is equal to 0 in y-axis. Okay, so that is what we infer from all the points. So now we have written equation for x-axis and y-axis. Similarly, we'll do for another set of lines. We have seen x-axis and y-axis, isn't it? Now we'll see for another set of lines. Now they are not on the x-axis or on the y-axis. We see somewhere outside x-axis and y-axis. See, we have drawn lines, straight lines passing through several points, isn't it? Previously we saw examples, straight lines crossing x-axis as well as y-axis. Now we'll see a line. See, I draw a line. This is parallel to y-axis. We know parallel lines, isn't it? So this line is parallel to y-axis. See, y-axis, the vertical line, I have drawn a vertical line through x-axis, but this line is parallel to y-axis. At what is the distance from the y-axis? It is 3 units, that is at 3. The line passes at 3. So the distance from the y-axis is 3 units. Okay, so that is constant. See, throughout, because we know parallel lines, throughout they maintain the distance between them, isn't it? So it is 3 units. Anywhere it is 3 units only. So let me mark the points along the line. So first this point is 3, 0, isn't it? So first this is 3, 0. Next I mark point here. So this is 3, 2. And if I mark a point here, this is 3, 4. Likewise, if I mark a point here, it is 3, minus 2. Here, it is 3, minus 3. See, I have marked a point 3, minus 5. See, along the line which is parallel to y-axis, I have marked all the points, isn't it? So, do you see any common point, common coordinate in all the points? Yes, isn't it? So, we have the abscissa to be the same in all the points on the line which is parallel to the y-axis. Do you understand? So a line drawn parallel to the y-axis has coordinates in which the abscissa is same, that is the x coordinate is the same, that is the x coordinate is constant. Okay, so constant, it doesn't differ. See, the y coordinates differ, the ordinates differ, but the abscissa is same, that is 3. So for this particular equation, shall we write this is x is equal to 3? So this equation x is equal to 3 is, isn't it? It suits this line because see, we have x is equal to 3, isn't it? In all the points we have x is equal to 3. Likewise, if I draw a line parallel to y-axis in this direction, see, x is equal to minus 4 here, or I can write it as minus 4, 0. If I mark a point here, it is minus 4, 2. If I mark a point here, it is minus 4, 4. And if I mark a point here, it is minus 4, minus 2. And here, it is minus 4, minus 5. So what do you observe here? See, here the distance is minus 4, isn't it? So the distance from the y-axis is minus 4 units. In this direction, it is minus 4. So the line parallel to y-axis on the negative side of the x-axis has minus 4. The axis has minus 4 throughout, whereas the ordinate changes. That means x is constant here, that is x is equal to minus 4. So this is the equation for the line parallel to y-axis at a distance of minus 4 units, and x is equal to 3 is the equation of this line which is at a distance of 3 units from the y-axis. So from this, what do we infer? parallel line to y-axis. Parallel line to y-axis which passes through x-axis. Its equation is x is equal to, say we can write a constant, x is equal to k, where k is some constant. In this case it is x is equal to 3, and in this case it is x is equal to -4. So this is how we get the equation for the line parallel to y-axis. So now we have seen a line parallel to y-axis, that is a vertical line. Now what is the other one? If I draw a vertical line, so then another line has to be, yes, the next line has to be, see, vertical line we have seen, the next line has to be naturally the horizontal line, isn't it? So we'll draw the horizontal line. X dash, y dash, origin. Okay, so 1, 2, 3, 4, -1, -2, -3 and 4. 1, 2, 3, 4, -1, -2. So these are, this is the Cartesian system we have drawn. Now let's draw horizontal line which passes through point 2 here. Okay, this is one line, let me draw it here, and the other line passing through -4. Okay, so first let us mark this point. This is 0, 3. Okay, now here let us take this point 2, 3. See, here it is 2, here it is 3. And let's mark a point here. This is 3, 3. X-axis is 3 and y-axis is 3. And here 4, 3. We have 4, 3. Likewise this side. This is -2, 3. And here it is -4, 3. So able to follow? See, we have all the points on the line which is parallel to x-axis. So the distance throughout being 3 units from the x-axis. See, from the x-axis, the line parallel to x-axis is 3 units. The distance between the parallel lines is 3 axes. Whereas here the distance is -4 units, which is maintained throughout. So the distance is -4. So -4, the distance -4, isn't it? From the x-axis we have a line parallel to x-axis. Now I'll mark a point here. So first this point 0, -4, and here this point is -3, -4, and this point is -2, -4, and this point is, see, 2 and -4, and this is 3 and -4. So if you observe the points, the coordinates of this line which is parallel to x-axis, you have -4 common. That is, the ordinate is common in all the points, isn't it? So here what I can write, see, y is equal to 3, because y is equal to 3. See, you have the ordinate same. It is constant, it doesn't vary, whereas the x coordinates vary in all these points. Here likewise the y coordinate, see, the ordinate -4 remains constant, whereas the x coordinates change. So I can write y is equal to -4 for this line, isn't it? So what do we infer from this? The line which is parallel to x-axis at a distance of some units, given units, you have a parallel line, and the equation is y is equal to the distance, that is the distance, it is written is a constant. So y is equal to 3 is the equation of this parallel line, and the parallel line to x-axis here is y is equal to -4 is its equation. Okay, from this we infer that parallel line to the x-axis is nothing but y is equal to k, where k is some constant, and that constant is the distance between the x-axis and the parallel line. Do you understand? So these are the lines, the lines from which we have derived the equations. So these equations, y is equal to 0, x is equal to 0, x is equal to k, and y is equal to k, represent linear equations of those lines we have represented here. Okay, so these are, some of the, actually this can also be written as y is equal to minus 4 can be written as y plus 4 is equal to 0, and this can be written as y minus 3 is equal to 0. Okay, so we can rewrite it in the form of equation. Okay, so these are some of the equations, the equations we have seen and we have represented it in graph 2. So hope you would have understood the concept of forming equations for x-axis, y-axis, and parallel lines to x-axis and y-axis. So in the next class, we'll see some more examples to demonstrate these equations in graphs, and some more verbal problems also, where we'll convert statement to equations and we'll find out the solutions for the statements and the unknowns in it. Okay, so until then, it's bye from Anu. Thank you.